This lesson covers permutation, combinations, and tree diagrams. Number 1, Donna must choose a size, a flavor of ice cream, and a topping for her ice cream dessert. There are 3 sizes to choose from, small, medium, and large, and 2 flavors to choose from, strawberry and chocolate. There are 2 toppings to choose from, nuts and cherries. So we have 3 decisions to make. So when we have decisions, I like to draw a blank for each decision. So we had a decision about size, and it was small, medium, or large, which are 3 choices. And then we had to pick our ice cream, which is strawberry or chocolate, so there were 2 choices. And then last of all, our toppings, and there were 2 to pick from for that. Multiply them all together, and that's our total number of combinations, 12. They made a tree diagram down here of it. So our first choice was small, medium, and large. And after we made that choice, we could pick either chocolate or strawberry. And then after we picked our ice cream, we had to pick either nuts or cherries on it. And that made then 12 different combinations to choose from. So how many outcomes are there possible? There were 12 outcomes possible. How many outcomes have just small or large? So small and then large down here, 2, 4, 6, 8. So there were 8 possible outcomes that were small or large. How many outcomes have both strawberry ice cream and nuts being picked? So strawberry and nuts, and strawberry and nuts, and there's a strawberry and nuts. So there were 3 of those possible. Number 2, Peaceful Travel Agency offers vacation packages. Each vacation package includes a city, a month, and an airline. The agency has 5 cities, 2 months, and 1 airline. So 3 different things that we're picking from, 3 different choices. And each one of those one has 5, then 2, then 1, multiply them together, so 10 different combinations possible. Number 3, when ordering kids' lunch at Burger Universe, a customer must choose a size, whether or not cheese, a type of bun, a side order, and a type of drink. So we're picking 4 different choices here. 1, 2, 3, 4, no, 5. There were 5 altogether. We had to pick a size, small or large, a cheese, with or without, a type of bun, white or wheat, a side order, and there were 4 sides, and then 3 different drink choices. Multiply them together, there's 96 different outcomes. Number 4, a technology company is going to issue new ID badges to employees. Each code will have 2 letters, followed by 1 digit, followed by 1 letter. The letters D, G, and Z, and the digit 8 will not be used. So there are 23 letters and 9 digits that will be used. Assume all the letters can be repeated. How many employee ID codes can be generated? All right, so we have 4 different things we have to decide on. We had 2 letters that we could have, which they said we had 23 to pick from each time. And then we could pick a number, and we had 8 different digits. They said we had 9 different digits to use from. And then we're going to have 1 more letter. And none of them are repeated, so we get to use them over and over again. So there's still 23 each time and a 9. Multiply them all together, get 109,503. Next up, learning a little bit about factorials. So working on factorials, this says 8 factorial times 4 factorial over 7 factorial times 2 factorial. A factorial means you count down from that number and multiply them all together. So that's 8 times 7, 6, 5, 4, 3, 2, 1. That starts at 4, count down, 4, 3, 2, 1. 7, count down, 7, 6, 5, 4, 3, 2, 1. And 2, count down. So when you multiply those together, what you can do is cancel things out. So if it's 8 divided by 7, all that's going to be left is just the number 8, because 7 down cancels out from the 8. 7 down is gone. And then 4 down and 2 down, 4 minus 2, you're going to get rid of the 2 and the 1. So all you're left with then is 8 times 4 times 3, which is 96. Your calculator does have a factorial key. It's under the math key over by probability. So if you wanted to, this one did fit in your calculator. Sometimes it won't work. Sometimes the number's too large and you're going to have to do some canceling. So the whole entire numerator on the top, I'm going to put a parenthesis. So 8, hit the math key, go over to the probability, and it's choice number 4, factorial. then times 4 factorial. So 4 back to math, over to probability, choice number 4, parenthesis divided by another parenthesis, because you want the whole numerator divided by the entire denominator. So divided by 7 factorial times 2 factorial, close the parenthesis, hit equals, and it's 96. Next up, it says evaluate 11 combination 7 and 7 permutation 4. So just to discuss what a combination of permutation is, up here I wrote it down. A permutation order does not matter. So it's kind of like if you play the lottery, you can box these numbers or not box them. So if you play them box, that means you're playing them that the order matters. And so if the winning number came up when they pulled it down to the digits, the balls, when they roll them around in the cube, the whole spinner thing, and then they pop out. So if the number popped out to be 3, and then the number 2 came out, and then the number 1, if you boxed it and you chose the number 3, 2, 1 in that order, you won more money because you ordered it the number boxed. And that's more rare to have that. If you didn't order it boxed, if the order doesn't matter, that's a combination. So if you had picked the number 1, 2, 3, for instance, you still won because that rearranged becomes 3, 2, 1. So the order doesn't matter. So when it's boxed, it's a permutation and the order matters. When it's not boxed, it's a combination. The big one here to remember, combination, you can have it in any combination that you want. It doesn't matter. So the order doesn't matter. So that's a way to remember it. Combination, any combination that you want. The order doesn't matter. When the order matters, it's called a permutation. All right, so down here, there's a formula for it. For a combination, the formula, the first number's n, the second number's r on both of them. So for combination, it's n factorial over r factorial times n minus r factorial. So for this combination here of 11 combination 7, it would be n is 11, so that would be 11 factorial, and then over r, and r is 7, so 7 factorial, over n minus r, so 11 minus 7 factorial. So 11 and 7, so 7 down cancels out with the 11, so that means you'd be left with 8, 9, 10, and 11, and then 11 minus 7 is 4, so 4 down, and so that ends up with 330. For permutation, n choose r, n permutation r, or this one says 7 permutation 4. So for permutation, the formula is n factorial over n minus r factorial. So n was 7, so 7 factorial over 7 minus 4, and then factorial. So cancel 3 down, so that would mean 4 and up is left. So 4, 5, 6, and 7 are left. Multiply them together, that's 840. Your calculator has a permutation combination key. Again, that's back on probability, so we're going to go to, you got to type in the number first. So we're going to do 11, go to math, over to the menu probability, combination, it's choice 3, and then we have to enter the number 7. So 11 combination 7, it gives you the answer that I got before, 330. And then go to the same place to find the permutation key. So 7, math, over to probability, choice number 2, permutation 4. So 7 permutation 4 is 840, which is what we got. Number 8. Well, actually 7. Number 7, Allie has been given a list of 5 bands and asked to place a vote. His vote must have the names of his favorite, his second favorite, and his third favorite bands from the list. How many different votes are possible? That means the order matters because you have a favorite band and a second favorite band, so you can't flip those because the second favorite isn't the same as what the favorite is. So the order on this one matters. So that's a permutation. So we had 5 bands and we're picking 3, so it'd be 5 permutation 3. And remember the formula on that if your teacher wants to see the work. Permutation was n factorial over n minus r factorial. So 5 factorial over 5 minus 3 factorial. So that gives you 5 over 2 factorial, which is 60. Or again, you can use that key on your calculator. So again, go to, let's see, you've got to enter the number first. So 5 and then math. And then it's permutation. So 5 permutation of 3. And you get our answer there of 60. Suppose we want to choose 3 objects without replacement from 4 objects. 3 objects without replacement from 4 objects. A pencil, eraser, desk, and chair. How many ways can this be done if the order does matter? If order matters, it's a permutation. So it'd be 4 choose 3 permutation. If the order does not matter, that makes it a combination. So it'd be 4 combination 3, which would give you the answers of 24 and 4. Number 9, suppose we want to choose 5 colors without replacement from 18 distinct colors. If the order of the choices is not taken, so that means the order doesn't matter, that makes it a combination of 18 and 5. If the order is taken, that means the order does matter, so that'd be a permutation of 18 and 5. And again, one more time on your calculator. So 18 permutation, so math, permutation 5, and that gives you that second answer there of, what is it? 1,028,160. And the other one is a combination, so it's 18 math, go over to probability, combination 5, and it gives you 8,568. So again, notice that there are less combinations than there are permutations of it. So if it's box, like I said, it's harder to find that number because the order mattered. If you picked 3, 2, 1, it has to be 3, 2, 1. So there's way more of those because the order of it matters, and there's less of it if the order of it doesn't matter. 3, 2, 1 is the same as 1, 2, 3 or 2, 1, 3. So that's how come if you don't box it, you don't win as much money. All right, number 10. Number 10, it says, from 13 albums released by a musician, the recording company wishes to release 10 in a box set. How many different box sets are possible? Now, I thought this one was kind of hard to understand what they wanted because, I don't know, when you have a box set, sometimes the order of it kind of matters to people, the way that it's boxed within the box. You don't want to put them in any particular... People get so picky about it, just like when you go to the library, there's certain places that you're supposed to put the book back on the shelf. Overall, people seem to feel there's a certain way to put things back in the box for CDs. If you've ever own CDs, I know that's not really a common thing anymore, but the order kind of matters. But since on the next problem, they definitely had one that the order matters on because they had a president, a vice president, and a treasurer. So there's specific jobs. So the order of who's picked for which job does matter because they're different jobs. If you were just picking 3 people to be on the committee, then the order doesn't matter because any 3 people or any 3, no matter how you mix them. So anyway, this one, the order did matter. So you would think that the order might matter on this, but it didn't. Order doesn't matter. That would be one that you'd have to argue about with your teacher when you got your test back and say why you thought the order did matter, or maybe ask them during the test, did you think the order matters? Because it's not honestly that clear. So since the order didn't matter, it was a combination. On this one, the order did matter for sure, without a doubt. So that made it a permutation. On number 11, a catering service offers 12 appetizers, 7 main courses, and 6 desserts. A customer is to select 8 appetizers, 2 main courses, and 2 desserts for a banquet. So we're picking 3 different things. So we kind of have 3 boxes to fill. And going back to number 1, how we filled in 3 different boxes, we're doing it 3 times here. We got 12 appetizers, and we're going to pick 8 of them. Then we got 7 main courses, and we're picking 2 of those. And then we got 6 desserts, and we're picking 2 of those. So then you multiply all of them together. And the order doesn't matter because when you're picking your appetizers, you're picking a selection of it. They're going to put them all out on the table. It doesn't matter. The order of it doesn't matter like it does when you line library books up on the bookshelf. I don't know, my bookshelf, it doesn't matter on, I just throw the books in there. So on, on Amy's bookshelf, order doesn't matter, but on the library, the bookshelf, it does matter. But anyway, when you throw your food on the table overall, the order doesn't matter. I guess you could argue though, maybe. Some people do care what order the appetizers are laid out on the table. I don't know. But no, the order doesn't matter. Last of all, we got the binomial formula. We're using the binomial formula to find the coefficient of y23s, and s didn't have a coefficient, so it's to the, well, not a coefficient, a power, so it's s to the first term, and the expansion of y minus 2x to 2s to the 24th. All right, so the binomial theorem again is a plus b to the n equals n combination 0 of a to the n b to the 0 plus combination of n choose 1 of a to the n minus 1 b to the 1, and so on. So adding those together, 23 plus 1 is 24. So we're doing a combination of 24, and we're picking 1 because that's the power of the second letter there, 1. And so this one, the first one, the a in this is y, the b is negative 2s, so it'd be y to the 23rd, and then the b, which is negative 2s, so negative 2s to the first. So 24 choose 1, anything choose 1 is still that same number, 24. Y to the 23rd, and then negative 2s to the first is still negative 2s. So that makes the coefficient 24 times negative 2, or negative 48. All right, if you still need some help, send me an email and I'll work it out with you. Have a good night.